Hello, my name is Surendra Reddy Gaddam. My roll number is 20ME10083. For my DIY assignment 2, I have made an fire alarm and an automatic fire extinguisher using Tinkercad. The components I have used for this project are an Arduino Uno, temperature sensor, red LED, piezo, two servo motors, 1 kilo ohm resistor, and an voltage multimeter. The problems targeted in this project are the fire accidents. We know that the fire accidents cannot be prevented, but the amount of destruction caused by them can be reduced. This is the main aim of the project. Here is the fire alarm and two servo motors which can be used to start the fire extinguisher. As soon as the fire goes up in a room, this buzzer makes sound and the LED glows. Even though we hear the buzzer, it takes some time for us to go to the room, take the fire extinguisher, and stop the fire. By the time we go into the room, the fire might have spread and caused some damage to the property and the lives in the room. So, I have made an automatic fire extinguisher using these two servo motors and a normal fire extinguisher. In the later time, I will explain where to place the servo motors in order to make an automatic fire extinguisher. Now, let us look into this circuit of the fire alarm in detail. Here, the positive terminal of the breadboard is connected to the 5 volt of the Arduino, the negative terminal to the ground, and the two positive terminals of the breadboard and the two negative terminals are connected to each other. Then, an LED in series with the resistor is connected to the breadboard. A piezo is also connected to the breadboard, and we connect a multimeter across the terminals of the piezo to check the voltage across the piezo. And temperature sensor is connected to the breadboard. The piezo is to make sound when a fire comes in the room, and the temperature sensor is to detect the rise in temperature of the room. The V out of the temperature sensor is connected to the pin A5 of the Arduino, and the LED is connected to the pin 13 of the Arduino and piezo to the pin 12 of the Arduino. Now let us look into the two servo motors. The power pin of the servo motor is connected to the positive terminal of the breadboard and the ground pin to the negative terminal of the breadboard. For this servo motor, the signal pin is connected to the port 1 of the Arduino, and for this servo motor, the signal pin is connected to the port 7 of the Arduino. Now, let us look into the coding part of the Arduino. First, I set the angle of the servo motor connected to pin 1 to 0 degrees and also servo motor connected to pin 7 to 0 degrees. Then, I created a variable called temp to record the temperature of the room in degrees Celsius. I assume that as soon as the fire starts, the room temperature will be more than 50 degrees Celsius. You can put this to any value as you wish. Then, as soon as the fire starts, the LED pin is set to high so that the LED glows and the speaker is turned on so that we hear a buzzing sound. And then one of the servo motor which is connected to pin 7 is set to 90 degrees so that the key of the fire extinguisher is pulled out and we wait for 5 seconds and then it returns to its original position. And then the another and till the temperature is reduced to 35 degrees Celsius, we constantly take the input from the temperature sensor and feed it to the temperature variable. And the other servo motor which is connected to pin 1 is set to 90 degrees in order to press the handle so that the chemicals from the fire extinguisher ooze out to put out the fire. This process continues until the room temperature reaches 35 degrees Celsius. And then the servo motor connected to pin 1 is brought to 0 degrees so that the handle is held loose, and also the LED pin IN is set to low. Now let us look into the simulation of the fire sensor and automatic fire extinguisher. As soon as we drag the slider so that the temperature crosses 50 degrees Celsius, the buzzer makes sound and the LED glows. Now here the potential across the buzzer is at a 2.2 volts. Now let us take a closer look on the servo motors. As soon as we drag the slider to 50 degrees Celsius, this servo motor turns 90 degrees to pull out the key from the fire extinguisher and waits here for 5 seconds and return to its initial position. And the other servo motor turns 90 degrees to press the handle so the chemicals come out of the fire extinguisher. As we turn on the fire extinguisher, the temperature starts to decrease. Now let us decrease it manually. As the temperature goes below 35 degrees Celsius, this motor goes back to its initial position so that the handle is held loose and the buzzer stops buzzing and the LED stops glowing. Now I will explain you about the placement of these two servo motors. First, let us assume that this is the XY plane and Z axis is pointing towards us. Now, for the placement of the first servo motor, place it here, and these two, let us assume that these two are the fans of the servo motor. Now, tie the key to a thread and connect this thread to the fan of the servo motor. If we assume that the servo motor rotates in the YZ plane in a clockwise direction, the motor rotates in this direction. It pulls the thread, thus pulling the key. Now, let us see the attachment of the second servo motor. You can keep the second servo motor like this and attach a pulley to the motor. Thread is tied to the handle and it is wound around the pulley. Now, as the servo motor rotates in the YZ plane as assumed, the pulley rotates, thus pulling the handle with the help of thread. Here, I am assuming that the hose of the fire extinguisher is already pointed to the place near to the fire sensor. I mean the temperature sensor. The salient features of the circuit is that I use a resistor to prevent the LED from bursting due to the excess voltage across the LED, and I also use a multimeter to check the voltage across the piezo. Now let us export the code to Arduino IDE. Here, click on blocks plus text, copy the text code. This is the Arduino IDE. Paste it here, click on verify. As you can see, this code is successfully compiled.